In the last video, we were looking at the gases present in clean and dry air. But in this video, we're going to look at some of the gases that exist in polluted air. Now, I'm not sure whether some of you all will recall during periods of haze in Singapore, when you switch on the television, you will see a number reflected which shows the PSI value. So have you ever wondered what PSI stands for? PSI actually stands for Pollution Standard Index. And how do they obtain the value that's reflected on your television screen? Is obtained by measuring the amount of the pollutant gases in the air. Okay, so if you can take a look at this table shown in this slide, you will see some of the important pollutant gases that we will be learning in this lesson. Now, there are 6 pollutant gases that we need to learn in the syllabus. The first 3 are the main ones, so you really have to memorize very well anything that's associated with these 3 main pollutants. For the next 3 pollutant gases, it's not as important, but they can still be tested. So what do we need to know about the 6 pollutants? Would be firstly the sources. So how is each pollutant formed? Okay, and next, the effects on the environment, the effects on humans. We need to know for each pollutant what are the negative effects. Now, before we go on to take a look at the sources and effects for each pollutant, a few reminders is this. Firstly, when you're stating sources and effects, please be specific. Later, I will show you an example of what is specific and what is not. So be specific when stating sources and effects. And especially for sources, there will be equations that tell you how the pollutant gas is formed. So you need to learn to write the relevant equations because you will be asked to write them in the exam. So the first pollutant that we're going to look at is carbon monoxide. The source of carbon monoxide is incomplete combustion of carbon-containing fuels. Okay, so when I say to be specific in stating the source, what it means is that you have to state incomplete combustion. Meaning, if you were to write combustion of carbon-containing fuels or combustion of fuels, that is not a good enough answer. Now, why do we need to state incomplete combustion as this? Firstly, what is combustion? Combustion is the reaction of a substance with oxygen, and usually to produce heat. So there are 2 kinds of combustions that may occur. So in the event where we have excess oxygen, that means we have a lot of oxygen present, and the other scenario is where we have limited, not enough oxygen. Now, when we have a lot of oxygen present, the combustion will be complete. And then when we have limited O2, we would have incomplete combustion. So when we have complete combustion, the products that will be formed would be carbon dioxide and water. And for incomplete combustion, most of the time, it will produce CO plus water. So I hope you can see here that complete combustion doesn't produce carbon monoxide as a pollutant, but only when the combustion is incomplete, only then you will produce carbon monoxide. Next, the effects of carbon monoxide would be that it binds irreversibly to hemoglobin, preventing blood from carrying oxygen to the different parts of the body. And what would that cause? That would cause headache, that would cause fatigue. When you have even lesser amount of oxygen in the blood, breathing difficulties, and then ultimately death. So when I say again to be specific in writing the effects, you cannot just say death. So state an effect of having carbon monoxide in the air, and if you write death, that is too vague an answer. You need to describe the whole part of CO binding irreversibly to hemoglobin, preventing blood from carrying oxygen, leading to headache, fatigue, and even death. The next pollutant that we're going to look at is sulfur dioxide. Okay, for sulfur dioxide, there are two types of sources. One is man-made, the other one is natural. So the one that's man-made is the combustion of fossil fuels containing sulfur. Alright, this will usually occur in factories or power plants. Next, the natural source of sulfur dioxide would be volcanic eruption. So when a volcano erupts, it actually spews a lot of sulfur dioxide into the air. Now the effects of sulfur dioxide would be eye irritation, lung damage, breathing difficulties, and so on. It has a very famous impact on the environment as well, which is that it will cause acid rain when you combine with oxygen and rainwater. Alright, it's so severe an effect that we're going to learn it as a standalone topic later. So in a later part of the chapter, we're going to learn how acid rain is formed from sulfur dioxide. Now before we go on to the next pollutant gas, which is your nitrogen monoxide and nitrogen dioxide, I just want you all to note this, that the effects for sulfur dioxide, the effects, they are the same for nitrogen monoxide and nitrogen dioxide. Okay, so when you memorize the effects for sulfur dioxide, essentially you are memorizing the effects for oxides of nitrogen. The next pollutant that we're going to look at is nitrogen monoxide and nitrogen dioxide. So collectively, we call them oxides of nitrogen. Similar to sulfur dioxide, there are two types of sources. One is man-made, the other one is it happens in nature. The man-made source is that it is present in the exhaust from internal combustion engines. What are internal combustion engines? They are the engines that are found in motor vehicles, in your cars, in your lorries. Later we will see how is it formed. The natural source is under lightning activity. So when there's lightning, the surrounding air would produce a lot of oxides of nitrogen. Now there's actually some interesting chemistry that goes behind the formation of your oxides of nitrogen. Now if you think about it, the compound, the pollutant gas contains nitrogen and oxygen. So how are they formed? They must be formed from nitrogen and oxygen. And the fact that nitrogen and oxygen are the main components in air, so they are found in abundance in air. So why don't they just simply react to give a lot of oxides of nitrogen? Why don't we have a lot of oxides of nitrogen in the air? So that tells us something, that the reaction doesn't occur readily, or rather it takes a lot of energy for the reaction to occur. So the question now is this: why would it require a lot of energy for nitrogen to react with oxygen? For that, we need to go back to the topic on chemical bonding. Now if you were to draw a dot and cross diagram to represent the bonding in nitrogen, I hope you can try it before looking at what I'm going to write. If you were to draw the dot and cross diagram for nitrogen, you will find that it looks like this. Once again, nitrogen is in group 5, so it needs to share 3 more electrons in order to have a stable noble gas configuration. Alright, so what happens is that nitrogen will form 3 covalent bonds to another nitrogen atom, For oxygen, oxygen is in group 6, so it needs to form 2 more bonds to become stable. So what you notice here is that nitrogen has a triple covalent bond, oxygen has a double covalent bond, so multiple covalent bonds. And for a chemical reaction to occur, we need to break these multiple covalent bonds. And because of the strong triple bond and the strong double bond present in nitrogen and oxygen respectively, it will require a lot of energy before they can react. So if we look at the sources again, in internal combustion engines, what happens is that we are burning fuel and the temperatures will be extremely high. Alright, same for lightning activity. The air surrounding a lightning, alright, due to the conversion from electrical to thermal energy, the air will be very hot, and under these high temperatures, okay, so high temperatures is a key element for the formation of oxides of nitrogen. Under the high temperatures, nitrogen and oxygen only then can react to form nitrogen monoxide. Okay, and after forming, nitrogen monoxide will react with some more oxygen to form nitrogen dioxide. Now we'll move on to the effects of having oxides of nitrogen in the air. As mentioned, it's exactly the same as sulfur dioxide. But one thing to note though, like sulfur dioxide, your oxides of nitrogen can cause acid rain. Now one thing to note, if we look at the oxides of nitrogen, we have NO and we have NO2. To both gases, will both gases contribute to acid rain? The answer is no. Alright, NO2 will contribute to acid rain, NO does not. Now why is that so? For that we need to go back to acids and bases. In acids and bases, we learn that there are different kinds of oxides. Non-metal oxides are usually acidic, except for 3 of them, which is your NO, CO and H2O. So NO is in fact a neutral gas, so therefore it doesn't contribute to acid rain. But NO2 and SO2, being non-metal oxides, they actually dissolve in water to form acids. So as mentioned, the first 3 pollutant gases are the major pollutant gases that you need to learn and will be tested most of the time. The next 3 pollutant gases, they are less tested. In fact, you only need to know the sources for the next 3 pollutant gases. The effects will only be good to know. So the first of the remaining 3 would be unburned hydrocarbons. What are hydrocarbons? Again, hydrocarbons are compounds that contain carbon and hydrogen only. So hydrocarbons are mostly found in the fuels that we burn in cars, in chemical plants, and sometimes when there is insufficient oxygen, this fuel is not burned at all. So it's not even incomplete combustion, it is not burned at all, so they are released in the exhaust gas. So an effect of having unburned hydrocarbons is that it will long-term exposure to them can lead to cancer. The next gas would be methane. Methane has the chemical formula CH4. In fact, it has a common name called natural gas. So how is it formed? It is formed when there is decay of animal matter, and a very famous source is that when sheep and cows, when they digest the grass that they have eaten, in whatever gas that they release, it contains a lot of methane. So the effect of methane is that it's actually a greenhouse gas. Again, later there is a section that is dedicated to greenhouse effect. We're going to look at greenhouse gases again. So methane is a greenhouse gas which will trap heat, that's radiated from Earth, and then too much of it can lead to global warming. And the last pollutant gas would be ozone. How is it formed is when nitrogen oxides react with unburned hydrocarbons, which produce ozone, which is represented by O3. And the presence of a lot of ozone in the air can lead to photochemical smog. Photochemical meaning is triggered by sunlight, and there's going to be a bit of haze. And what this haze causes would be eye and lung irritation. So as mentioned, the last three gases that we just saw, we only need to know the source. We don't have to really memorize the effects, and they are less tested compared to the first three pollutant gases. Earlier we saw that there were two pollutant gases that can lead to acid rain. So in this part, we're going to look at how the gases actually form acid rain. So the first gas is sulfur dioxide. So what happens when we have sulfur dioxide in the air is that you will first react with water, and upon reacting with water, it forms your sulfurous acid. Okay, this is sulfurous acid. And what happens to sulfurous acid is that it's going to react with more oxygen in the air. It's going to react with more oxygen in the air to form sulfuric acid. So what happens when you have sulfur dioxide in the air is that it's going to react with water and oxygen in the atmosphere to form sulfuric acid, which is a strong acid, which therefore leads to acid rain. Next, for nitrogen dioxide, what happens when we have nitrogen dioxide in the air is that your nitrogen dioxide is going to again react with oxygen and water to form nitric acid. And nitric acid is again a strong acid, so it's going to cause the rainwater to become acidic. So what I've shown here are the equations which represent how the pollutant gases sulfur dioxide and nitrogen dioxide form acid rain, how they react with oxygen and water to form acid rain. Now it's very important for you to remember the equations because they are often tested. So you'll be required to write the equations that illustrate the formation of acid rain from either NO2 or SO2. Another question that you will be commonly asked about acid rain is the effects of acid rain. So you need to mention that they corrode metal and limestone buildings or structures. Again, it's very important to be specific in stating your effects. So when you say that it corrodes buildings, you may not get the mark because you have to be specific. It doesn't corrode all kinds of buildings. It only corrodes things that can react with acids, for example metals, and limestone being your calcium carbonate. So other effects include that it will lower the pH of lakes, therefore your aquatic plants and animals cannot survive. It leaches nutrients from the soil, so plants cannot survive.